We look up at the night sky and think we know what's out there. Stars, planets, maybe some aliens if we're lucky. But space doesn't care what we think. It keeps throwing mysteries at us that break our instruments, shatter our theories, and leave our best scientists staring at data they can't explain. 12 discoveries that make no sense. 12 puzzles that mock everything we thought we understood about the universe. If you value documented space science and astronomical discoveries like this, subscribe. It's the best way to support our work. Also comment from which city you're hearing this from. This script is researched and factual, using sources from NASA's astrophysics data system and peer-reviewed journals from Nature Astronomy. Now back to the story. Number 1, the WOW signal, 1977, Ohio State University's Big Ear Radio Telescope. August 15th, 10:23 p.m. Eastern Time. 72 seconds of radio waves so strong, so focused, so impossible that astronomer Jerry Emmons circled the printout and wrote one word, "Wow." The signal came from Sagittarius, near the hydrogen line at 1420 megahertz. The exact frequency hydrogen atoms emit when electrons flip spin states. Natural hydrogen broadcasts weakly across the universe. This signal screamed 30 times stronger than background noise. The Big Ear used 2 feed horns separated by 2 arc minutes. The signal hit the first horn, vanished, then appeared in the second exactly where Earth's rotation predicted. Whatever transmitted stayed fixed in space while our planet spun underneath. The telescope's beam was 72 seconds wide at that declination. The signal filled every second. Never repeated. Never explained. The telescope listened for decades after. Silence. Whatever sent that signal either stopped talking or moved on. The coordinates point to empty space between Chi Sagittarii and Tau Sagittarii. No stars. No planets. No known source of radio energy that intense. Number 2, fast radio bursts discovered 27 years later. Millisecond flashes of radio energy that release more power in 5/1000ths of a second than our sun produces in 3 days. The first one hit the Parkes telescope in Australia, buried in data from July 19, 2001, but not found until Duncan Lorimer's team analyzed the archives in 2007. Since then, over 500 more. The Lorimer burst came from the small Magellanic Cloud's direction, 200,000 light-years away. 5 milliseconds of radio fire brighter than anything in our galaxy. Some repeat, most don't. FRB 121102 comes from 3 billion light-years away and flashes every 157 days like clockwork. 16 bursts, then silence, then 16 more. The precision makes no sense. Neutron star collisions can't repeat. Magnetar starquakes randomize. Black hole mergers happen once. The source sits in a star-forming region of a spiral galaxy. Young, hot, massive stars surround it. Yet the bursts arrive with timing accurate to 13 minutes across 2 years of observation. Alien technology remains the explanation no one wants to say out loud. Harvard's Avi Loeb calculated the power requirements. A solar panel array 20 times Earth's diameter could collect enough sunlight to produce these bursts. But why pulse? Why repeat? Why stop for months then start again? The mathematics work for artificial beacons. The implications terrify. Accused. Detected. Unexplained. Number 3, dark flow, discovered 2008. Entire galaxy clusters streaming toward one edge of the observable universe at over 2 million miles per hour. Not expanding with the universe. Moving through it. Alexander Kashlinsky's team at NASA's Goddard Space Flight Center found 800 clusters all flowing the same direction, toward a region in Centaurus and Hydra. Something beyond our cosmic horizon is pulling them. Something bigger than anything that should exist. The Wilkinson Microwave Anisotropy Probe mapped temperature variations in the cosmic microwave background. Hot spots mark dense regions that became galaxy clusters. Cold spots mark voids. The hot spots should move randomly as the universe expands. Instead, they flow coherently across 4 billion light-years. The Great Attractor was supposed to explain local motion, a gravitational anomaly pulling our local group at 600 kilometers per second. This flow spans distances 10 times larger at speeds 4 times faster. Kashlinsky's team measured the kinetic Sunyaev-Zeldovich effect in over 700 clusters. When galaxy clusters move through the cosmic background radiation, they create temperature shadows. The shadows all point the same way. Every cluster from 1 billion to 4 billion light-years distant flows toward the same 20-degree patch of sky. The effect weakens with distance but never disappears. Something beyond our observable universe, something with mass equivalent to 10,000 galaxy clusters, exerts its pull across the cosmic horizon. Number 4. The cold spot in the cosmic microwave background. 2004. 1.8 billion light-years across. 70 microkelvin colder than surrounding space. The Wilkinson probe mapped it. The Planck satellite confirmed it. The spot covers 6 degrees of sky in the constellation Eridanus. Standard cosmology predicts temperature variations of 10 microkelvin at most. This anomaly runs 7 times deeper. Rudolf Schild at Harvard calculated the void's properties. To create this temperature deficit, empty space must span 1 billion light-years with galaxy density 20% below average. The Eridanus supervoid fits perfectly, but supervoids shouldn't affect the cosmic background radiation. The light we see traveled 13.8 billion years from the universe's edge. Voids formed later when the universe was already transparent. They can't imprint their shadows on primordial light. Some call it evidence of parallel universes pressed against our own, draining heat through dimensional walls. Laura Mersini-Houghton's equations predict exactly this effect when bubble universes collide during inflation. The mathematics work. The implications rewrite cosmology. If our universe touches others, the cold spot marks the collision point. The boundary between realities, frozen in the sky's most ancient light. Number 5. Tabby's star. Catalogued as KIC 8462852, 2015. Kepler Space Telescope watching for planets found something else. Brightness drops of up to 22%. Irregular. Unpredictable. No known object blocks that much light from a star 1400 light-years away in Cygnus. Not planets. Jupiter transiting our sun dims its light by 1%. Not comets. Even swarms dissipate within years. Not dust. Infrared observations show no heat signature from absorbed starlight. Tabitha Biagian led the analysis with citizen scientists from Planet Hunters. The dimming events lasted days to weeks with no obvious pattern. Between 2009 and 2013, the star faded 20% overall. Historical photographic plates from Harvard's collection show century-long dimming trends. Whatever blocks this star's light operates on multiple timescales simultaneously. Every natural explanation failed. Planetary ring systems can't survive around F-type stars. Asteroid swarms melt in stellar winds. Dust clouds disperse in centuries, not millennia. The alien megastructure hypothesis survives because nothing else fits the data. Dyson spheres built by advanced civilizations could create these exact dimming patterns. Incomplete constructions. Orbital swarms of solar collectors. Technology harvesting stellar energy on scales we can barely imagine. If you value documented space science and astronomical discoveries like this, subscribe. It's the best way to support our work. Also comment from which city you're hearing this from. Now back to the story. Number 6. The Axis of Evil in Cosmic Background Radiation. 2005. Max Tegmark named it after finding patterns that shouldn't exist. The universe's oldest light shows temperature variations aligned with our solar system's ecliptic plane and equinoxes. The cosmic microwave background should look identical in all directions. The same temperature, the same tiny fluctuations, the same statistical properties. Instead, it points at Earth. The quadrupole and octopole moments in the temperature map align with our planet's orbital plane and rotation axis. Coincidence probability: less than 1 in 60,000. Kate Land and João Maguejos at Imperial College confirmed the alignment using multiple analysis methods. The effect persists across different map-making techniques, foreground subtraction methods, and statistical tests. Either we occupy a special position in the universe or our fundamental assumptions about cosmology are wrong. The implications shatter the Copernican principle. For 400 years, astronomy has assumed Earth holds no special position. We orbit an ordinary star in an ordinary galaxy in an ordinary region of space. The cosmic background radiation suggests otherwise. The universe's largest structures somehow know about our tiny planet's orientation. The alignment spans 13.8 billion years and 28 billion light-years. Whatever created this pattern encoded Earth's future orbital mechanics into the universe's birth. Number 7. The galaxy with no dark matter. NGC 1052, discovered 2018. 65 million light-years away in the Coma cluster. Galaxies are supposed to be 90% dark matter by mass. This one has none. Zero measurable dark matter within detection limits. Dark matter holds galaxies together through gravity. Without it, stars should scatter like marbles from a broken jar. These stars stay put in perfect rotation curves. Peter Van Dokkum's team at Yale measured stellar velocities for 2 years using the Keck Observatory. They tracked the motion of 10 globular star clusters orbiting the galaxy's edge. Normal galaxies show flat rotation curves. Outer stars orbit as fast as inner ones because dark matter provides extra gravitational pull. NGC 1052 shows declining rotation. Outer stars orbit slower, exactly what visible matter alone predicts. The galaxy formed through unknown processes. Computer simulations can't reproduce its properties. Tidal interactions with nearby galaxies might strip away dark matter, but they also disrupt stellar orbits. This galaxy's stars remain undisturbed. Either dark matter theory is incomplete or this galaxy represents a new class of object formed through physics we've never seen. The discovery challenges our understanding of galaxy formation, structure formation, and the nature of dark matter itself. Measured, verified, impossible. Number 8. The Boötes Void. 1981. Robert Kirshner found it surveying galaxy positions for the Harvard-Smithsonian Center for Astrophysics. 330 million light-years across. Almost completely empty of matter. Should contain 10,000 galaxies based on cosmic averages. Has 60 scattered around its edges. Local galaxies call it the Great Nothing. The supervoid occupies 0.27% of the observable universe's volume but contains 0.02% of its galaxies. Light takes 330 million years to cross the void at the speed of light. Inside, space is so empty that if Earth sat at its center, the nearest large galaxy would lie 150 million light-years away. We wouldn't know other galaxies existed until the invention of the most powerful telescopes. The Milky Way would appear unique, alone, the only island of stars in an endless dark ocean. How something this vast stays this empty defies structure formation models. Computer simulations of the universe's evolution can't create voids this large. Dark matter should collapse into filaments and walls, but the Boötes region remained nearly pristine. Greg Aldering's supernova surveys confirmed the void's extent. Type Ia supernovae, cosmic standard candles, appear in expected numbers everywhere except here. The absence spans 300 million years of cosmic history. Number 9. Oumuamua. October 19, 2017. Our solar system's first confirmed interstellar visitor detected by the Panoramic Survey Telescope and Rapid Response System in Hawaii. 600 feet long, 30 feet wide, spinning every 7.3 hours. Not a comet, no coma, no tail, no outgassing signature despite approaching within 0.25 astronomical units of the Sun. Not an asteroid, accelerated away from the Sun without rocket engines or visible mass ejection. Abraham Loeb at Harvard calculated the trajectory. Oumuamua entered our solar system at 26.3 kilometers per second from the direction of Vega. As it rounded the Sun, something pushed it faster. Not gravity that would slow it down after perihelion. Not solar wind, insufficient force for an object this massive. Not outgassing, spectroscopy detected no volatile compounds. The acceleration required a force equivalent to solar radiation pressure, but Oumuamua's surface reflected less than 10% of incident light. The numbers match exactly what you'd expect from a light sail, artificial material designed to catch stellar photons for propulsion. Loeb's calculations show that a sail 1 millimeter thick could produce Oumuamua's observed acceleration. Natural objects don't form with these dimensions. The 6-to-1 length ratio exceeds any known asteroid or comet. Something made this object. A probe, a sail, technology from another star system, tumbling through space for millions of years before gravity brought it home. Number 10, the universe's missing lithium. Big Bang nucleosynthesis predicts specific amounts of light elements formed in the first 20 minutes after cosmic birth. Hydrogen makes up 75% of normal matter. Helium comprises 24%. Lithium should account for 0.00001%. We find the hydrogen in exact predicted abundances. We find the helium matching theoretical calculations. We find 1/3 the lithium we should. The Planck satellite measured the cosmic microwave background with unprecedented precision. The temperature fluctuations encode the universe's composition at 380,000 years after the Big Bang. Baryon density, photon density, and nuclear reaction rates all match Big Bang models perfectly. Lithium-7 production depends on the same parameters. The predictions are rock solid. 2/3 of primordial lithium vanished without trace. Stellar fusion destroys lithium, burning it into heavier elements inside stellar cores. But stars formed hundreds of millions of years after Big Bang nucleosynthesis. Something else consumed primordial lithium in the universe's first moments. No known physics explains the deficit. Hypothetical particles, exotic nuclear reactions, and modified gravity theories all fail to solve the lithium problem. 3 times less than predicted across 13.8 billion years of cosmic evolution. Predicted, calculated, missing. Number 11. Type Ia supernovae that shouldn't exist. White dwarf stars have a fundamental mass limit discovered by Subrahmanyan Chandrasekhar in 1930. 1.4 times our Sun's mass, the Chandrasekhar limit. Exceed it, electron degeneracy pressure collapses, and the star explodes as a Type Ia supernova. This limit is absolute. Physics prevents white dwarfs from growing heavier. Period. Except SN2003FG in galaxy NGC 4414, discovered by the Lick Observatory Supernova Search. The spectrum showed silicon and sulfur absorption lines characteristic of Type Ia events. The light curve matched standard candle predictions perfectly, but the explosion's properties required a white dwarf with 2.1 solar masses when it detonated. Impossible. The white dwarf was too heavy to exist as a stable star. Rodrigo Scalzo's team at Australian National University modeled the explosion using spectral analysis and light curve fitting. Only Super-Chandrasekhar white dwarfs produce the observed silicon velocities and peak luminosity. The progenitor star somehow grew beyond the theoretical mass limit without immediately exploding. Either stellar physics contains loopholes we don't understand, or something created conditions that allow impossible stars to exist temporarily before violent death. Number 12, the Fermi bubbles. 2010. Gamma ray streaming from our galaxy center discovered by the Fermi Gamma Ray Space Telescope. 50,000 light-years tall, 25,000 light-years wide. Visible in gamma wavelengths, invisible in optical light. The structures dwarf everything in our galaxy, extending from the galactic plane to beyond the Magellanic Cloud's orbital distance. Doug Finkbeiner at Harvard found them hiding in the Fermi All-Sky Survey data. The bubbles emit gamma rays with energies from 1 to 100 billion electron volts. No known astrophysical process creates such perfectly symmetrical structures on these scales. They formed 2 to 4 million years ago in a violent eruption that released energy equivalent to 100 million supernovae exploding simultaneously. Something at our galaxy's center went nova when our earliest ancestors walked the African savanna. Sagittarius A star, our central black hole, weighs 4 million solar masses but currently accretes matter at barely detectable rates. Too quiet to power the bubbles. Too stable for major outbursts. Yet 2 million years ago, it somehow generated more energy than our galaxy's entire stellar population. The bubbles preserve evidence of this ancient catastrophe, glowing with residual gamma radiation from particles accelerated to near light speed. The eruption carved cavities in the galactic halo, swept up surrounding gas, and launched material at thousands of kilometers per second. Shock waves from the event still propagate through intergalactic space. Our ancestors lived through this cosmic violence without knowing their galaxy was screaming gamma rays into the void above and below the Milky Way's disk. Last year, archaeologists found a new chamber in the Great Pyramid using cosmic ray muons. The void sits above the Grand Gallery, 40 feet long, untouched for 4,500 years. Space archaeology works because cosmic rays penetrate stone. They also penetrate time. Light from the cosmic microwave background traveled 13.8 billion years to reach our telescopes carrying information about the universe's birth. In that ancient light, we see patterns that shouldn't exist, alignments that point at Earth, and temperature variations that violate our most basic assumptions about cosmic democracy. The WOW signal broadcast for exactly 72 seconds from empty space, then never repeated. Fast radio bursts flash with clockwork precision from galaxies billions of light-years away. Dark flow pulls entire galaxy clusters towards something beyond our cosmic horizon. The universe keeps its deepest secrets in plain sight, written in wavelengths we can measure but patterns we can't explain. We built the instruments to detect these mysteries. We just haven't built the theories to understand what we're seeing.